I am going to go to math. So I'm in the matrix mode, and I click over to math. All right, so second matrix, and then over to math, right there in the top row. I need you to go all the way down that column until you find R, R, E, F. Okay? So all the way down that column. That stands for reduced row echelon form. So we're going down to R, R, E, F, press enter. Then go back into matrix. And the calculator wants to know, what are you going to RREF? Well, you're going to RREF matrix A. So press enter. And enter again. And it will spit out a new matrix. And the new matrix looks like this. So is there anybody in the room that got that? Okay, good. Believe it or not, this gives me my answer. Because remember when you put the matrix in, these were X's, Y's, Z's, and equals, right? That's where those numbers came from. Now when they come out, it's the same thing. So this literally says X equals 4, Y equals 0, and Z equals 2. So my answer is 4, 0, 2. That is the answer to the system. Okay? All right, so now we're going to do B. This is the last one. We're going to go through this carefully. All right, so you need to pay attention. Lock in. All right, we're locked. We don't have time to mess around with this. Notice that problem B has 4 letters and 4 equations. So the matrix that I put in is going to have a column for X, Y, Z, W, and the equals number. Not every equation has all the letters though. So I put zeros in the right spot for what's missing. So I have it in my top equation, I have an X, a Y, a -1, a 0, and a 4. So there's my top equation. Now my bottom one, or my middle one, and the next one, my second one, does not have an X. It has a Y, no Z, a W, and -4. If it's missing, it gets a 0. Next one has a 1X, a -1Y, no Z, no W, and it equals 1. And the last one has an X, no Y, a Z, a W, and it also equals 1. So you are going to write that down on your paper, okay? And then you're going to write the new matrix after you RREF it. And that's going to give you your answer. So that's really all you have to do. Write down what goes in, write down what comes out, and then what does that tell you about your answer? So how do we get it in? We second matrix and click over to edit. What are the dimensions of this matrix? That's the first thing you have to tell me. It is 4, 1, 2, 3, 4 rows, 1, 2, 3, 4, 5 columns. So it's 4, enter, 5, enter. That's how big it is. So then I'm going to put all these numbers in. Just type over the old numbers. Make sure you're putting in negatives using your negative button, not your subtraction button. And as soon as you get this last number put in, and you hit enter, so type it in and hit enter, then you're going to second quit. You're gonna get out of there. You're done editing, quit, done editing. Then you're gonna go back into matrix, second matrix, over to math, down to RREF, and then back into matrix, enter.
Is decimals okay?
Decimals are fine. Decimals are part of life. And the matrix that came out looks like this.
Yeah.
So what does that mean to you? If your directions were solve, so that means your answer is 4.5, 3.5, 4, and negative 7.5. And especially if your letters aren't in alphabetical order, it's a good idea to like label them. So that's what we've got. If they're in alphabetical order, like if it's X, Y, Z, it's okay. But if they're out of order, like ours were, when we put them in, then it's a good idea to label them.
We do count it off.
Yes, do what I say, Jake. Okay.
How do you know which letter?
All right. Problem C. You and your partner try problem C.
This is for. How do you know which letter is which?
They're in the order you put them in the equation.
Oh.
When you put in X, Y, Z, W, that's the order they're gonna come out. All right, so you're working on problem C now. Jake, I wanna see that pencil working on that paper.
Good grief.
Can I ask you a question, Miss Moore?
What?
Are like the X, Y, and Z like dimensions? They're like, and if you think about it, like X is the coordinate, Y is like one.
Yes, yes.
So what would the W?
Now you're into 4 dimensions. What is the 4th dimension? Right?
Oh.
It doesn't have
There
a
is
geometric
that letter.
concept that, you know, some people say time or whatever, but yeah, these are dimensions.
Time is its own dimension. And just start talking about it.
Bro, what?
What? He is right.
Once we transcend that.
Burger, dad. Jobs.
I don't know why you're talking.
Jobs, right?
Did you hear Ronan? You said, I don't know why you're talking.
All right, I hear way too much extraneous crap. I need everybody quiet. Second matrix edit, that's where you start. Watch your dimensions here. This is a smaller one.
Yeah, we both did. You messed up.
I got 23 and 13.
Oh, we're supposed to do G2. Alright, I'm gonna do this.
I got that.
Wait for the last one also.
You have it?
So what is this?
Wait, you do?
You got a book part.
Good luck finding their house.
Just getting ready to pretend how they're fighting. Wait, I'm just ready.
You see the Vaughn story?
Yeah, the one's like kind of rat out.
Yeah, he's trying to sell people out for $5.
Of course, he's a hustler by nature.
What they do.
Yep.
I know what they like to do.
Maybe they can get some training into the pockets, right?
Bro, I watched every single one of those, of like the stories on the cruise. Every single time I see the videos, like, oh bro, you might sit down like that.
Bro, he's not even an on bro type of guy though. Like,
Hey, you guys were doing a video on this.
Right.
I heard on his story, whenever all you hear was you guys were off on a cruise and you say something about finally have Wi-Fi service.
Okay, I need everybody to be doing D also.
Yeah, it's ugly. You can just round it off.
Exactly. Okay, no, wait.
Okay, sorry.
I need everybody listening. When you get to the point in problem D, or whatever this one is, this last one, when you do your RREF, and up comes the new matrix, as the guy said, it's ugly. It's full of decimals, right? Okay, so here's how I want you to handle that. That is the kind of situation that happens when I don't rig the problem, okay? Chances are, if I just make up random numbers, it's going to come out yucky like that. So what you're going to do is, on your regular keyboard here, hit math, the math button, and the first option there is frac. So hit enter a couple of times, maybe twice, like math, frac, and it will take that matrix, take all those ugly decimals and change them into ugly fractions. But at least you're not gonna round off. And that's the goal. So when you do that, you come out with Alright, so if you're doing it right, these are the matrices that came out when you did problem C and problem D. Okay? But we need to talk about this because both of these problems have an issue. I want to go back. I did not write down, who wrote down the first one? All right, I want to go back and look at the answer that we got to the first problem that we did. That's what it looked like, right? And the other one looked the same except had decimals and stuff in it. There is a huge difference between that answer and this answer. They are the same size. But again, you need to understand what this new matrix is saying. It is literally saying that 1x plus no y's plus no z's equals 4. That's what that says. Well, no y's and no z's, I can ignore that, so x equals 4. Okay? Now, tell me what this row says right here. That row says no x's, no y's, no z's equals 0. Now, first of all, is that a true statement?
Yes.
Yeah, that's true. If that number right there had been a 1 or something, then that would be a false statement. Because nothing can't add up to be 1. But it's a 0, so that's a true statement. That means, you guys, that Z literally can be anything. Because it wouldn't matter, like, let's say you got ZD5. Would that still be true? Yeah. So, how we deal with that is, I'm doing problem, this one, so the one that is. How we deal with that is, when you get a whole row of zeros, which, by the way, you also have here, we're gonna have to deal with that. When you get a whole row of zeros, you say, literally, Z can be anything. So Z is Z. So Jillian might make Z5, and he might make Z negative 17, and you might make it 11, and that's fine. But X and Y depend on your Z. Here's what I mean. Let's look at the second row. What does this row say? Y plus 3 Z's equals negative 13. So Y equals negative 13 minus 3Z. So Z, the all zero row is the Z row. This is the X row, the Y row. This is the Z row. Z can be anything. So let's say Jillian lets Z be 5. That's okay. But if Jillian lets Z be 5, then her Y is going to be negative 28. But if Elijah lets Z be negative 1, then his Y is going to be negative 10. Your Y value depends on the Z value that you picked. So how many answers could there be? Infinitely many. We can't possibly write them all down, so we're going to write it generally. Z is Z, Y is negative 13 minus 3Z. What's X? Well, X minus 4Z equals 23. So what does X equal? 23 plus 4Z. So I got my Z row turned out to be all zeros. So that means I have what we call a parametric solution. I have Z equals Z. Then I solve for Y, get Y by itself, get X by itself. And now, if I pick a Z value, I can find a matching Y and X. To write this answer, normally we write it in an organized fashion. And the organized fashion would be like this. See if this makes sense to you. So those things in the box, I just wrote in an organized, coherent way. Notice that every letter, like X for example, has two parts. It has a number and it has a Z. So here's its number and here's its Z. So 23 plus 4Z. Y is the same thing, negative 13 minus 3Z. Now X doesn't have a number. It just has one Z. Or I say X, I mean Z. Z doesn't have a number. It's 0 plus 1Z. Now having done that, now we're going to do this one the same way. So you've already typed this in, and my letters are A, B, C, D. And this is what came out. Notice you have a row of zeros. So how are you going to handle the row of zeros? Start there. What does that row say? D equals D. This is your D row. all zeros, so D is D. Now, what does this row say? This row says C, 1C, plus 3/11 D equals negative 7/11. So what does C equal? Negative 7/11 minus 3/11 D? What does the B row say? B plus 5D equals 5. So B equals 5 minus 5D. And finally, what does the A row say? A negative 3/11 plus 38/11 D. Is that right, Elijah?
Yep.
So now what is I'm gonna organize my answer. I'm gonna write the same thing, just organized. So my variables are A, B, C, D. I'm gonna have plain numbers and then D's. So what is A? Plain number is negative 3/11. D is 38/11. C, or B, I'm doing B, so B is 5 minus 5, negative 7/11, negative 3/11, and then 0, 1.
Yep.
There's no number, this is like 0 plus 1D. Now, when do I have to worry about this? I don't have to worry about this very often. I only have to worry about it when about the whole row goes to 0. When you do RREF and the whole row goes to 0, then that means you're gonna have an answer that looks like this. So that isn't the normal situation. Okay?
Okay.
All right, 7.4, so 7.3 is due on Wednesday. 7.3 due on Wednesday. Here we go, 7.4. Find the area of a triangle with these vertices. This is one of the coolest things ever. Ever. This is cool. There's a triangle up there. And the vertices are 1, negative 1, 3, 2, and negative 1, 7. We could do the law of cosines, find an angle, do 1/2 side sine, but that's gonna take forever. We could do Hero's formula, but that would take all these distance formulas and I'd have round off all over. I'm gonna show you a way that is so cool, you are going to be just floored. All right? So here's what I need you to do. Pick a point, A, B, or C, I don't care, pick one.
B.
All right, you pick B. If we pick B, then we are going to write the coordinates of the vector from B to C and from B to A. So you are allowed to pick any point you want, but then that becomes your starting point. So A or B to A, B to A, and B to C. If you chose point A, then you would do A, B, and A, C. Okay? Now, here we go. As you move happens to your x? You go from 3 to -1. Goes back 4. What does your y do? It goes from 2 to 7. Up 5. So these are actually the coordinates of that vector, but you just need to think about it as the directed distance. How are we moving? From 3 to -1 and from 2 to 7. Now do the same thing from B to A. So 3 to 1. That's 3 to 1. -2, gotta have a direction, positive or negative. And then 2 to -1. Down 3. Okay, if you don't get these numbers right, you won't get the answer right. So does everybody follow where those came from? All right. Now I want you to make a determinant out of those things. So just right here, just like that. So -4, 5, -2, -3. So those two things you wrote down, and the order you wrote them doesn't matter, so you could have BA on top. That would be fine. Evaluate that determinant. So do you remember how that works? Multiply 12, multiply -10, and subtract. So the value of that determinant is 22. Divide it by 2, and that's the area of the triangle. So the area of this triangle is 11.
Bro, I did something wrong.
That is way faster than any other method that we have. And there's no round off. Remember, the area of the triangle is always 1/2 something, 1/2 base times height, 1/2 side times sine. So remember, after you find your determinant, you have to divide it by 2. All right. Number 2.
Why are we doing rational?
Is it like an emergency?
Yes, really, not, it really is. Thank you.
Wait, is that the only example I have?
Where is it?
All right, that's the only example I have. So let's go through the steps one more time. What did I do first? Oh, you know what? Let's do the same triangle using another point, see what happens. So let's use point A. What would be my coordinates if I use point A? What would be AB? AB would be 2, 3.
2, 3, yeah.
And AC would be -2
And 8.
8.
Oh, this is if we pick different points?
Yes.
Oh, I was like,
Yeah, you were like 4.
Now, let's find that determinant. So that'll be 16 minus -6, which is 22, and half of 22 is
11.
Plus 5, 16.
Now, I said a minute ago that you could have these in a different order, so you could have BA first. If you did that, and you did the determinant, it might come out to be a negative number. That's okay, just make it positive, okay? Area can't be negative. So if you do this, and you, let's say we've got -22, we would just make it positive, be positive 22. All right? Okay. Next, find the partial fraction decomposition. What in the world? What in the world?
Yeah, I'm good with that. I got it.
So by partial fractions, we mean the two little fractions that when you add them together, we give you this. All right? So I want you to think uncommon denominator. All right? So I had two fractions, I made a common denominator, added them together, and got this. Any idea what these two denominators might be?
Got factor like that.
That factors, that's exactly
You
right.
like puppy dogs.
So x minus 5,
Plus
x
three.
plus 3.
Yeah, so that's the
So that is step 1. Factor the denominator, and then those factors become the individual denominators of the two little fractions. Okay, that's step 1. All right? Step 2, clear the fractions. So in other words, you're gonna multiply everything by this. So if I multiply everything by x minus 5, x plus 3, that will get rid of all my denominators. This is gonna cancel totally, leaving me with 5x minus 1.
equals x plus 3.
This is gonna leave me with a times x plus 3
And b x minus 5.
and b times x minus 5. So what do you think about that? Did everybody follow that move?
Sort of, yes.
Sort of, kinda, or yes.
Sort of, kind of. But you can do that. We're moving pretty quickly.
We are, but that's life and
We
fast
have to,
lane.
exactly.
I do drive it fast though a lot, so.
I want you to drive carefully.
Yes.
Have you seen him drive?
Do you know that?
He does
you're
not
driving?
drive carefully.
I drive carefully.
He does not drive
We
carefully.
get a lot of hops on
Okay, Dana,
You're lying.
Yeah, listen,
Dana,
it's not, he gets you to the destination 3 minutes
class of
quicker.
96,
It's not like that.
going to Notre Dame. Everybody joked with him all the time about how he drove fast and took chances.
Yeah,
The night before baccalaureate, he hit a tree and died.
and we just saw that happen recently too. I don't
I
drive.
don't want that to happen to you.
Yeah, well,
So be careful.
I really feel
All right, here we go. Next thing we do is we got rid of our denominators. This is what we have left. So 5x minus 1 equals ax plus 3a plus bx minus 5b. So what is that? I simply distribute it. Turn around. Sam, that's you too. This is where sometimes the confusion sets in, and I don't understand it, because it's very obvious. This is an equation, an equals. So however many x's you have on the left, you have to have that many x's on the right.
That makes sense.
So how many x's do I have on the left?
1.
5.
5.
Oh.
How many x's do I have on the right? A plus b. Those are numbers. And when I add my ax and my bx, don't I need to get 5x?
Yeah.
So 5 has to be a plus b. And then what does negative 1 have to be? Well, it doesn't have an x. So it has to add up to 3a minus 5b. Are you agreeing with that? Okay, now what is that? That's a system of equations that you can either use substitution, elimination, Kramer's rule, any of those will work. So I love to eliminate, so I'm gonna multiply the top row by 5. You can do whatever you want. So it looks like A equals 3. And if A equals 3, it looks like B has to be 2. So I'm gonna write my answer now, and this is the way the answer has to be written. Go back to the way you set it up. 3 over x minus 5 plus 2 over x plus 3. It's not enough to tell me A and B, because if I had written these two in a different order, if I had written x plus 3 first, then A would be over x plus 3, and that A would not be the same as my A. So you have to put it like this. You have to put your A over your A denominator and your B over your B denominator. If you have time and interest, if you got a common denominator and added these together, guess what would happen? You would get this. All right? I don't like example B because it's too hard. We're not going to go into it that hard. So let's get our homework out and look at in 7.4,
Oh, 25 equals 5.
problem 2. In the 7.4 homework, problem 2. Because it is more like what you have to do on the test.
No, I got it.
So, the problem in the notes is a little bit more complicated, and I'm not gonna quiz you over that, so I'm just not gonna do that, we don't have time. But, we're gonna do this one, this is from the homework. This is like you will have to do on your own, alright? So let's see if we can remember the steps. What was the very first thing we did? Factor. Alright, so let's get these things back. How does that look? So then what do I do? Why did I factor? So I can set up my little fractions. Each factor gets a fraction.
Plus 17.
Now I'm going to multiply, and you don't need to write this down, but you can, if you want. I'm gonna multiply everything by both factors. If I multiply this by both factors, then I'm just gonna have x plus 17 left.
Yeah.
But if I multiply this by both factors, the 2x minus 1 will cancel, but I will be left with the x plus 3. And likewise here, the x plus 3 will cancel, but I'll be left with the 2x minus 1. Okay? Now, distribute. So x plus 17 equals ax plus 3a. It's regular distributive, guys. Nothing fancy. 2bx minus b. Now, it's an equation. So anything with an x, you have to build an equation for. So on this side, here's the equals. On this side, I have 1. And on this side, I have a plus 2b. 1x equals ax's plus 2bx's, and don't put the x's in.
What about the other A?
I haven't gotten there yet,
But-
because it doesn't have an x. So I built an equation with
Oh,
the
the
x's.
X's.
Now I'll build an equation for all of the other things. So 17 equals 3a minus b. And then substitute, eliminate, Kramer's rule, whatever you want, because you got a system of equations, you gotta figure out what a and b are. So if I multiply the bottom one by 2,
Oh, I know that, yeah.
it looks like a is 5,
Yeah, I got that.
and if a is 5, is b negative 2? I got negative 2 for b. Did you?
Yeah.
Alright. So then, we write our answer, 5 over 2x minus 1 plus negative 2 over x plus 3. Those are your partial fractions. Those are the little fractions that add up to the whole big problem. Okay? Now, number 3. This is review. Alright, this is review. Do you remember earlier in the year sketching these things that had asymptotes and all that in them? So here we go. Let's see what we can remember. I'm gonna go ahead and factor. Nothing cancels, so who remembers what information that gives me? If nothing cancels, there are no holes. Alright, I'm back in my notes now, guys, sorry. I'm back in my notes from 3a. So tell me what you do have here. I don't have any holes because nothing canceled out. So what do I have?
You have the vertex, which is the
I have,
bottom.
I have vertical asymptotes at positive 3 and x equals negative 3. Those are my vertical asymptotes. Because where do vertical asymptotes come from? The denominator. I have 2 things in the denominator, so I'm going to have 2 vertical asymptotes. The x-intercepts come from the numerator, so 2, 0, and negative 2, 0. Those are my x-intercepts, also called zeros, and they come from the numerator. Very good. What else do you remember? If we plug in 0, I get the y-intercept. So if I plug in 0, and you can do it here, or it might be easier to do it at the original. If I plug in 0 in the original, I get 4/9. So 0, 4/9. This was a problem on your first semester exam, it's gonna be a problem on your second semester exam, let's pay attention. right along.
Oh,
Nah, you're good, bro.
Aiden, how about a horizontal asymptote? Does anybody remember how we do that?
It's their, if the X
You put it in, you plug it in.
one.
No, the horizontal asymptote
Oh, it's
comes
cross out.
by boxing in x squared over x squared. That's one. So your horizontal asymptote is going to be at 1, y equals 1.
Is 4, does that say 4 over 9?
Yeah. Because that's what you get when you put in 0.
Huh?
Now, does anybody have an idea what this thing looks like? I heard a parabola. Does everybody kind of see a parabola right here?
Yeah,
Yeah.
it goes downwards.
Alright, got that part. What's happening over there on that side? Or this side? Yep, that's exactly right, Joe Garvey. It looks just like this. Remember these things, you guys? We got them all the time.
Okay, Joe.
How did Joe know that they were up here?
Because of the acid.
What would happen if they were down here? What would they have to do if they were down here?
There's an intersect.
They have to cross an axis and they can't.
Okay.
So that's it. Good job.
Good, Joe.
All right. B.
Great job.
Yep, nope, got one more to go. I'm gonna go ahead and factor as I go.
Hey.
I know where your house is.
Okay, stop it. We don't care where his house is. We don't care about any of that. I want you to stop and focus.
Exactly, we're mad.
Now, I factor. That is a necessary skill that you must possess.
And I don't think
I noticed when I factored that I could cancel. So that means there's going to be a hole. And it is going to be where x is -1, because that's the factor that I canceled out. Who remembers how I find the y part?
Plug in
Plug in -1. So that's gonna be 4 over 2. I got -2/3. Double check that for me when I put in -1. So there's my hole. Nice open dot at -1, comma, -2/3. Now, this is what I'm graphing. X-intercept comes from numerator. So the x-intercept is gonna be at -5. Y-intercept comes from plugging in 0. So that would be 5 over -4. Vertical asymptote comes from the denominator, so x equals 2. And horizontal asymptote comes from comparing your x squares. So you have x squared over 2x squared, so that will be y equals 1/2. Alright, so back through that quickly. The whole came from the cancellation. So -1 is the x that canceled. And then I plugged that in and got -2/3. Vertical asymptote comes from the denominator, x equals 2. Horizontal comes from x squared over 2x squared, 1/2. X-intercept comes from the numerator, so -5. And y-intercept came from plugging in 0. Now, any thoughts on what this looks like?
It's a downward.
Right here, it looks like this, right?
Top right as well.
And then the other piece is opposite it. Alright, it's a reciprocal function, exactly, it's a version of the reciprocal. So, we will finish this up next time.